Good afternoon, my dear students. Yesterday, I think we discussed the concept of what the one-dimensional inelastic, perfectly inelastic collision. Okay, so I think what I remember the last point yesterday I told the loss of kinetic energy in the completely inelastic means perfect inelastic. Perfect or completely, any word you can use. Completely or perfect inelastic collision. In 1D, one direction, not 2D, in 1D, is delta Ke is equals to half m1 m2 by m1 plus m2 into u1 minus u2 whole square. This is actually the formula we use in one-dimensional collision. Okay. Two-dimensional, we have to use the basic formula. Yesterday, I explained with one example also. Okay. Separately calculating the total kinetic energy before the collision, total kinetic energy after the collision, and subtracting the two. Okay. What I gave the homework problem, I think Parsu I gave one problem day before. Okay. Here coming to the today's class. Here, if you come to few basic models, like one example, if you take here, suppose from a support, this is the support, and from the support, I am suspending here one mass by means of a string, okay, massless and inextensible string, and suspending a mass here. This is a mass suspended. Take it as wooden block, okay, it is the wooden block of mass m, okay, capital M I take. And here, suppose it is bombarded, means collided with, like suppose here, this is the bullet, okay, not 6 feet bullet, small bullet. Of mass, small, okay. It is moving horizontally without changing the direction, one dimensional, directly hits the wooden block with a velocity u, penetrates, and suppose after penetrating, number one, first model, number one, after penetrating, if the bullet stops inside, bullet stops inside, what happens? So both, if they want to move, both will move combinedly. This is what I am saying, comes under perfect inelastic. So the what the wooden block and the bullet, where is it? Here inside, okay. This one is, sorry, this one is inside, like this. It is the bullet penetrated, okay. Both bullet and mass tries to move forward, with what velocity, if you ask, like this. Both combinedly move with a velocity, say v. Then I write here, after penetrating, both the bullet and the block combinedly move with the same velocity How much is that? All of you know. In the perfect inelastic collision, the same velocity, common velocity v is equals to, since it is one dimensional, no need to write even bars also. Directly you can write m1 u1 plus m2 u2. No need to take the vector form, divided by m1 plus m2. Okay, that I write here. First one, m1 is the bullet, small m. M2 is the block, capital M, divided by M plus M, I write. Okay, into U1, I write. Bullet is before striking, it travels with a velocity U. So M into U plus, before striking, here it is not taking the warm up, not moving that side and this side. It is at rest. Okay, it is at rest means its velocity is 0. Okay, so I'm getting the common velocity here. Both combinedly move with a velocity, the formula mu by m plus m. Okay, this is the common velocity in case the bullet stops inside the wooden block. Common velocity of block and bullet. Okay, but look at here, Nana. When it tries to move, problem is the combined mass can't move like this in the same direction. Why? Because after penetrating and stopping the bullet inside, it is suspended to the string. That's why, like a pendulum, it should go like this, like a pendulum. Okay. So problem is it can't travel like this. This is what I'm saying. Okay. It travels like this, like one arc of a circle, and it comes to a new position here and stops there. Why? Because it is trying to go against gravity. So velocity gradually decreases, 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 and maybe here that velocity is 0. That becomes 0. Okay. So there I am taking its velocity is 0. So what I am doing here, the final velocity here 0. Then the question is, by taking it as the reference level, okay, from that level to what height, like the pendulum, here the wooden block raises? This is the question. To what height it raises? That black line, double arrowed black line, is the height. Okay, h is equals to how much? That is the question, Anna. Then here you can say, since both are moving combinedly, I can write here, sir, here it is started with a velocity v, sir, raises to a height h, sir. So it is appeared like a body thrown vertically upwards, sir. So indirectly you are asking what is the maximum height attained. Maximum height attained in that chapter, h is equals to, already we know, sir, u square by 2g. Here u means from this position it is started, both combinedly started with the velocity v, sir. So v square by 2g, where v already I know, sir, no need to substitute, sir. After doing some calculation by the given numerical values, we calculate v and that we try to substitute here, sir. You can use it as a shortcut, nothing wrong in it, I accept. H is equals to v square by 2g to find out the height. Sir, no, sir, something fishing here, sir. I don't accept this formula, sir. Will you explain it more clearly, sir? Why not? Come to here. Suppose if I take it as a reference level, this one, it is the reference level. In the same color I am writing, that line, violet line. I think you know in your 10th class what is the potential energy of a body, what is the kinetic energy of a body, what is the total energy of the body, and the total energy is constant between 2 points, called as law of conservation of energy. Okay, you have some idea about that. So here, while moving from the position A to position B, what I am going to do, the total energy at position A is equals to the total energy at position B. Means using another method or using the law of conservation of energy. The law of conservation of energy. Simple. Okay, LCE. Total energy here initially at the first position here. Potential energy formula, you know, mgh. On the reference level, height is 0 and mass both are combinedly moving m plus m. So mgh plus kinetic energy is half mv square. V is V only at this position. Mass is again combined mass m plus m, I write here. Okay. This is the total energy at the first position. This one you take it as first position and this is the second position. And total energy at the second position you write. Final velocity is 0. So happily I write the kinetic energy half mv square is 0. But problem is it raised to a height h. Combinedly, both raised to a height h. Why? Because bullet is inside the block. So combinedly m plus m g into it is raised to a height h mgh. That's it. So according to law of conservation of energy, total energy at the 2 points equal. By equating these two, I think you know this part is 0. So half I'm going to write in the next page. M plus m into v square at the first position is equals to, look at that, at the second position it is just m plus m into gh. So here we can understand that m plus m get cancelled. I am getting v square is equals to 2gh cross multiplication. Of course, unnecessarily we brought the 2 to the other side. I asked h. So h is equals to, I am getting again bringing back to the total term here to the denominator, v square by 2g. Look at here, just using the shortcut I told already, the maximum height attained when at the lowest point the velocity is v. Okay, since you smelled something here, fishing, so I tried to explain with another method here. Okay, in both the methods, we got the same formula. So h is equals to v square by 2g. No need to highlight. Already I highlighted that formula here. Okay, this is the another way of getting the value of h. Okay, and number 3 here, since it is perfect inelastic collision, after penetrating inside, they may ask what is the loss of kinetic energy. Okay, so here next point, what he is asking, one is what I said, the height. This is the first one. Okay, and the loss of kinetic energy during the collision. Okay, during the collision means the total energy before is not equal to after. During the collision, something is wasted. So during the collision, I am directly using the shortcut formula, Nana, half m1, m2, small m and capital M by m1 plus m2, m plus capital M into u1 bullet velocity u minus u2 block is at rest before the collision. At rest means u2 is 0. That already I substituted here. Okay. So u2 is 0. So u1 is u2 is 0 means the subtraction you are getting u minus 0, that is u. So half m by m plus m into u square. This is delta ke. Okay. Same question they may ask when you come to the mains type of exam. they try to confuse. If they ask what is the loss of energy, those who remembered the perfect inelastic collision and the loss of energy in that perfect inelastic collision, particularly in one dimensional, directly that student will try to substitute all the values given here and try to calculate the answer like this. Okay. What the confusion there, sir? They may ask, find the fraction of loss of kinetic energy. Fraction means what he is saying. Suppose the total kinetic energy of the bullet means half mu square. He says some 50 joules. And the kinetic energy of the block, that is at rest before the collision. Okay. Its energy is 0. So total kinetic energy of the system before the collision is 50 joules total before the collision. Okay. In that, by substituting all the values here, suppose delta Ke, I got 10 joules. 10 is in the 50, how much the fraction if they ask? Simple, I say, delta K is nothing but 1/5 of total energy. Okay, so 1/5 is the fraction here. 1 by is fraction, how you get? 10 by doing 10 by 50. 10 by 50 means delta K is 10 by 50 is total kinetic energy before the collision. Okay. So by doing delta Ke by total kinetic energy before the collision, you will get the fraction 1/5. So here within numerical, I explained, Nana. Okay. Same thing there in the formula, you try to substitute what I said. The fraction is total delta Ke divided by total before the collision. Okay. So fraction is nothing but delta Ke divided by before the collision total energy is half mu square plus that is 0 Ohm block. Okay. So from here, what I am saying by erasing this part. Okay. Moving back to there. Delta K already you got here, Nana. This is half m by m plus n into u square divided by, he is asking half mu square. So half cancel, small m cancel. I will cancel it another color. Here half cancel, m cancel, u square cancel. So answer here getting what that implies fraction is equals to, simple I'm getting leftover terms are capital M by m plus n. Okay, so keep in mind this is the fraction of loss of kinetic energy. Okay, keep it as a shortcut. If it is useful in numericals, you can use it straight away. Instead of calculating the total loss of kinetic energy divided by total initial kinetic energy and then taking the ratio directly without calculating anything here, you just take the fraction with the masses, given masses. Okay, this is a shortcut now. Keep in mind. Okay, these are the possible questions what they ask in case of the block suspended by means of a string and bombarded with a bullet fired horizontally, and in that the case one is if the bullet is stopped inside after penetrating. Okay, not like this. Suppose the thickness of wooden plank here suspended is small. Okay, like the target what they place while firing the bullets during that practice. Okay, They fire the bullets here, try to firing into this small circle. Okay, there the board thickness is small, so bullet will easily penetrate to the other side. So such a type of target. Here, thin wooden plank, if I suspend, and the bullet suppose comes out of this plank, okay, then the question, here he is asking like this. Better I take the model 2 here. This is the one. And number 2, I'm taking. Again, the diagram I'm taking here like this. Suspended. And this is the wooden plank, what I'm taking here. Oh, this is the wooden plank, what I'm taking here. Okay, but thin. And here, of course, taking same mass of this one is capital. And this is the bullet, what I'm taking here, fired horizontally. Bullet mass is also same, small m, fired with a velocity u, strikes horizontally with a velocity u. And problem is, since the thickness is small, it won't stop inside. It penetrates and easily comes out with certain velocity. Suppose given as u dash comes out with a velocity u dash. Now bullet is not there inside. So who will try to move forward? Because of loss of some energy here, the wooden plank will get some energy and tries to move. Only wooden plank this time tries to move forward. Why? Because bullet penetrated, immediately came out and says bye to the wooden plank. Okay. So the person Papam who is forced bachelor here tries to move forward. Only the wooden plank. Suppose moves with a velocity v, then the same question. Since it can't move forward, why? Because suspended. So it tries to move like this. And suppose its velocity becomes 0 here, like in the previous one. Then again the question is, what is the height attained by this only wooden plank? Why? Because once again I'm repeating, the bullet already came out. Okay, this is the small wooden plank, but of same mass. Okay, here final velocity is equals to 0. And as usual, this is the reference line. Okay, from this reference line, as usual, I'm taking this is the height. Whether the same height it goes or different height it goes is the question. If it is h, then again the question is h, how much? Okay, that h, since only the wooden plank is trying to move with a velocity v to raise to a height h, again I write h is equals to v square by 2g. Okay, but don't judge by seeing the formula here and there. Sir, there I got h is equal to v square by 2g. Here also v square by 2g. Formula same. But whatever you are going to substitute in place of v, that v what you got here is equals to the same v here you get or not. That you check once. That's it. If you get the same formula for the velocity of the wooden plank here v, like mu by m plus m, then your answer is correct. There and here it raises to the same height. Sir, here how to calculate this V, sir? Just check whether it is perfect inelastic collision or inelastic collision. Sir, bullet not stopped inside, sir. Okay, just touched the heart, broken the heart and came out, sir. Okay, with the broken heart, only the wooden plank here raises up, sir. Okay. So here this Papam wooden plank alone is moving means it is not coming under perfect inelastic. If both combinedly move, that is perfect inelastic. Okay. Oh, it is inelastic. Inelastic means we should not use the formula V is equals to M1 U1 plus M2 U2 by M1 plus M2. We should not use. Okay. So striking off, this is not the valid formula. We should not use this formula. Okay, striking here. Then what to do, sir? Inelastic collision means any type of collision obeys the law of conservation of linear momentum. So why you leave the basics here? Just try to use using the law of conservation of linear momentum, the fundamental formula. Between two bodies, that two one-dimensional, without bars here, no need to put any bar. M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2 you write. Okay. M1 already we took in the previous model also as small m. M2 is capital M here and there, both sides, right hand side and left hand side. And here U1, before the collision, its velocity is U. And take care, after the collision, for the first particle, after the collision is V1, it has some velocity that is U dash. You have to substitute here. I think you understood. Okay, for the bullet, before the collision, after the collision, means U1, V1. Okay, now you come to U2, V2. U2, already I told there is no warm up. It is at rest before the collision, it is 0. But after the collision, often the forced bachelor started to move with V. So after the collision, its velocity is V. Okay. So you see here whether you are getting the same formula or not. Okay. Check. This becomes 0. It is mu, and take this one to the other hand, minus mu dash equals to capital M into V. In this case, V is equals to, I am getting small m common, U minus U dash divided by, I got capital M. Look at there. You got the same formula here and there? Surely no. That's why here, whatever you are going to substitute in place of V is not same as in the case 1. Since V values are not same, even though formula is same, the heights what you get here and there are different. Okay? Right. So here you may ask, sir, wisely you tell, sir, where it gets more height, sir. Okay, I understood what you explained. Since V values are not same here and there, I accept, sir. Heights are not same. Okay. But where the height will be more? Simple. That's why I explained with another method here, with the law of conservation of energy. Okay. If the loss of kinetic energy is more kinetic energy is transformed into potential energy and it will raise more. Sir, this is a little bit confusing, sir. Okay, no problem. Then check here. Okay. I will give two numericals. Try to solve the two. Okay, you can understand very easily. Simple, no need to find out h. Where the v is more, there the height is more. Why? Because h is directly proportional to v square. So simple. Okay, will you try? Yes, come to here. This model actually we call with some name as ballistic pendulum. So you may see this word while solving the numericals. Okay, a ballistic pendulum is suspended from a support. Then don't ask me, sir, he gave one new name, sir, ballistic. Never you explain this concept, sir. Okay, ballistic pendulum means this model only. Okay, there again two models, stopped inside and comes out here like this. Okay, so straight away to avoid a lot of words there, directly I'm coming to in ballistic pendulum. Okay, directly I'm coming to small m and capital M values I will give here. Like this is say um, mm, this is 100 grams nano, means 1 2 3 0.1, and this one I'm taking it as 1.9 kg. Okay, in both the cases, here in case 2, the bullet, oh, initial velocity I did not give nano. Okay, I take it here. U is equals to say some 500 meters per second. Bullet now, so it travels with more speed. Okay, okay, 500 meters per second. In case 2, the bullet comes out with a velocity of 100 meters per second. Okay, find the heights raised in both the cases. In both the cases. Okay, with the example, you will get more clarity. So better we take one example. What is that? Okay, come to the solution. Okay, first case 1, Nano. Case 1 means stops inside. Case 1, V is equals to, no need to turn back. I remember the formula, mu by m plus m. Okay, here given that m is 100 grams, 100 means we should not substitute. Why? Because other value is given in kgs. So I take it as 0.1 kg. 1, 2, 3, correct one. And capital M is 1.9 and U is already given in the question, that is 500 meter per second square. Second. Just substitute all the values here, you will get the answer. Okay, going to substitute here. V is equals to, I am going to get M 0.1, U 500 divided by m plus m plus m 1.9 plus 0.1, that is 2. So this becomes 50, 50 by 2, 25 I'm getting meters per second. That implies in case 1, h1 is equals to, I will get v square by 2g. Better I write it as v1, v1 square. Okay, is equal, means this one, v1. That is 25, 25 is a 625 by 2 into g 20, 62.5 by 2 means 31.25 meters. The answer is. Okay, just keep in mind the value. And come to case 2 now. In case 2, no need to actually turn back. If you want to see, you can see it. The formula for V is V in case 2. I write it as V2 in case 2. Here that I got m into u minus u dash by capital M. Okay, so m is 0.1, u minus u dash 500 minus 100 divided by capital M is 1.9. This one is 400, 400 divided by point cancel after one decimal, 1 by 19. Okay, 90. Okay, and 19 means here you can say this value as 19 twos are 38, 20 means 19 ones are 19, 10, 10 means 0, 19 fives are 95. Very small, approximately 21 you can take it, 21 meters. Okay, 21, sorry, meter per second. Here you can say happily, sir, that is 25, sir, this is just 21. Means in second case, the height will be less. Directly you can say. That implies here H2 is equals to, again the formula V square by 2G, means this time V2 square. 21 whole square by 20. 21 whole square is how much? 441 by 20, if I'm not. So here 441 by 20 means that is equals to 44.1 divided by 2, 22.05 meters. Now you see how much less you are finding out there and here. So that's what I told. In the first case, you will get more loss of kinetic energy. Okay, that's why here the height raised will be more. Means the loss of kinetic energy is transformed into potential energy. That's what I'm saying. Okay, transformed into potential energy means more loss, more gain. That loss is transformed into potential. That's why in first case the height raised more. Okay, means finally I conclude here the conclusion in the next page. Note, you write here what in case of stopping inside in bracket completely inelastic, you are finding out the height raised, okay, is more, okay, in this one ballistic pendulum is more. That you try to remember. Okay, and number two, note here point one, point two, in case two, suppose if they ask, already you calculated Nana, what is the loss of kinetic energy and what is the fraction. Same 2 points, suppose if I ask there also. The loss of kinetic energy equals to how much? If they ask, that you have to calculate, Nana. Total kinetic energy before the collision, that is half m into u square. Okay, kinetic energy of the bullet plus kinetic energy of the block is 0. Total kinetic energy before minus total kinetic energy after, half m into only bullet. Bullet comes out with u dash, I think I took there. Yes, u dash square. This is the kinetic energy of bullet plus kinetic energy of the block. The forced bachelor, only the block moves with a velocity v. Okay, I think given in the previous page, v. So here half capital M into v square. Okay, don't try to calculate here, Nana. That becomes a big one again. Like this is half M u square minus half capital M u dash whole square plus a half M into v square, means again I have to substitute that value here. M into u minus u dash by capital M. Okay. M into u minus u dash whole square by capital M. By solving this whole thing, finally you may get like this. Like here is equals to, I think, minus of plus minus. Sorry, no. Here it is minus of plus. Okay, right. Minus here. What I remembered, half m u square minus half m u dash square whole into m minus m, you will get, and here plus separately you will get m square into half m v square, means, sorry, here also I have to write whole square. Okay, whole square here. Right, v, this is v value, v square, correct one. M square into u dash you will get. This is what I said. Don't try to remember this formula. Better you do like. Okay, what is the total kinetic energy before? What is the total kinetic energy after? Why? Because you are not getting like a small shortcut what we got in perfect inelastic. You are not getting such type of comfortable equation. So better don't try to derive, just I tried for your sake. Okay. Better you try to remember it as like total before minus total after. Okay. You do that in the numericals. Okay. Just keep it in a box, but don't try to remember. This is what I got loss of K in case delta K. If they ask the fraction, that also don't try to do it on a fraction means delta KE. You calculate separately in exam divided by total KE before is that is always half mu square. Why? Because before the collision only bullet is in motion. So half mu square Planck that is 0. This is delta K. Don't try to write anything here. Simply leave it. This is the fraction, Nana. Fraction of kinetic energy here in this case. Means we are not getting like comfortable equations like in the previous one. Okay. Suppose if you ask, I said both here, like what is the fraction, sir? What is the loss of kinetic energy? Okay. I think you understood here, Nana, what I said. Okay. So these are actually few examples related the perfect inelastic collision and inelastic collision. Okay. So here for tomorrow, just I'm giving one small introduction. Suppose if you come to not perfect inelastic, suppose if you come to inelastic collision, where those two are not sticking together and not moving commonly. After the collision, they are moving separately like this. Okay, like with the different velocities, V1 and V2. Sir, in this type of collision, when we come to exam, they will give M1 sir, M2 sir, U1 sir, U2 sir. But directly they ask what are their velocities after the collision. Means being a mathematics student, if I think in any type of collision, I can write only one equation, that to one dimensional sir. M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. I can write. But problem is you're asking two unknowns, whereas you give only one equation. With one equation, how will we get two unknowns? Where is the other equation? According to mathematics, what we know, Sharat sir told, to find out two unknowns, we require two equations. So where is the second equation, sir? Okay. Likewise, if you poke me, okay, in the middle, then I say my answer. I will explain that second equation. I will give that second equation in the next class. Okay. Why? Because you did not ask me, you poked me. That's why I will give the answer, okay, in the next class. Okay. But if you have any doubts, you can ask in the next class, Nana. Okay. For today, I'm stopping the class. Bye, everyone, Nana.